Mathematics Class 12 Chapter 6 Application of Derivatives. We shall do exercise 6.2. Question number 1. Show that the function fx equal to 3x plus 17 is increasing on R. I will use definition to prove this. That is, x1 less than x2 implies f of x1 less than f of x2. This is the definition of increasing function. Let us consider two numbers x1, x2 in R such that x1 is less than x2. We shall get like this function here. So first I will multiply by 3. So multiply by 3 both the places, 3x1 less than 3x2, inequality will not change. Then here plus 17, so add 17 both the side. So plus 17 plus 17, still inequality will remain the same. So what we have proved, this is f of x1 and this is f of x2. So f of x1 less than f of x2. That means by definition f is strictly increasing on R. Question number 2. Show that function fx is equal to e power 2x is increasing on R. I will differentiate this with respect to x. So derivative of fx is f dash x and e power 2x is e power 2x. You have to do 2x once again, that is 2, x is 1. Now this value will be always greater than 0. Even if I take x equal to 0, e power 0 will be 1, so answer is 2. So greater than 0. So for all the values of x, this is greater than 0. So we can say function is increasing on R. Question number 3. Show that the function fx is equal to sin x is number A increasing in 0 to pi by 2, that is first quadrant, decreasing in pi by 2 to pi, that is second quadrant, neither increasing nor decreasing on 0 to pi, that is first and second quadrant together. So first I will differentiate this sin x with respect to x. So f dash x is equal to cos x. Now we know that in the first quadrant, that is 0 to pi by 2, all trigonometric functions are positive. So cos also is positive. Since f dash x equal to cos x is greater than 0 in first quadrant, that is 0 to pi by 2, fx is increasing in 0 to pi by 2. Part B. In the second quadrant, cos is negative. Since f dash x equal to cos x is negative in second quadrant, fx is decreasing in pi by 2 to pi. Now in first and second together, that is 0 to pi. So f dash x equal to cos x is greater than 0 in first quadrant, less than 0 in the second quadrant. But if I put value pi by 2, that is between 0 to pi, then cos pi by 2 is 0. That is, f dash x does not have same sign in 0 to pi. So f is neither increasing nor decreasing in 0 to pi. So that is the answer for the all three part. Okay, we have proved all three part. Question number 4. Find the interval in which function fx is equal to 3x square minus 3x is A increasing, B decreasing. Here we are going to use the theorem, and the same technique we'll use for the finding the interval. Okay, we have to find the interval here. So first is differentiate. So I differentiate this function, differentiation with respect to x. This will be 2x square, so x square will be 2x, so 2 into 2 4x, minus 3x is 1. Now next is we have to equate this with 0. So when you equate with 0, 2x minus 3 equal to 0, so equal to 3, and divide by 4, so x equal to 3 by 4. Now I have to divide the number line into the interval minus infinite to this value 3 by 4 and plus infinite. So I have got two interval, minus infinite to 3 by 4 and 3 by 4 to plus infinite. So this value will be 0 point something. So I have got the two values. So I will take one value in this interval, minus infinite to 3 by 4. Okay, so let us take, it is this value is something less than 0, this is 0 point something, so I'll take some negative value. So if I take some negative value, let us say minus 1. So you put minus 1 here, 4 into minus 1. Okay, so 4 minus 4 minus 3, answer is negative. So I get negative answer. If f dash is negative, then decreasing function. Okay, so I have to write interval, sign of f dash x, nature of f. And here sign of f dash x for the first, when I take here negative value or in this interval, answer is negative, so it is decreasing function. Now I'll take value this side, that is 3 by 4 to infinite. So I'll take some positive number here. So let us take 1. So if you take 1 in this, so you have to check the sign of f dash x. So you take 1. So 4 into 1 is 4 minus 3, which is positive. So answer is positive. If this f dash x is positive, that means it is increasing function. So we can say the given function is increasing in the interval 3 by 4 to infinite and decreasing in minus infinite to 3 by 4. So that is the answer. And this is the same technique we are going to use to find any interval for increasing and decreasing function. Question number 5. Find the interval in which fx is equal to 2x cube minus 3x square minus 30x plus 7 is number A increasing, number B decreasing. Again the same way we are going to do, first differentiate, then after differentiating equate with 0, solve for x, find the intervals and check the sign of f dash x. Okay, so first I will take this, fx is equal to 2x cube minus 3x square minus 36x plus 7, differentiate with respect to x. So f dash x, 2x cube is 3x square, so 2 into 3 6x square minus 3 into 2 6x minus 36, x is 1, this is 0. From all these three I can take 6 common, here remains x square minus x minus 6, then I have to equate with 0. Now f dash x equal to 0. Okay, after differentiating equate with 0 and then solve for x. So when I solve this I will split the middle term, so it comes minus 3x plus 2x. 2 into 3 6 and 3 minus 2 is 1. So from here I can take x common, so I get x minus 3, here 2 common, so x minus 3. So I get the value x minus 3 and x plus 2. Okay, so these two value I get. So equal to 0, that means either x equal to 3 or x is equal to minus 2. These are the two solution we get, also two values of x we are getting. So now I have to divide the number line according to this. Okay, so this is my number line and I divide according to this. So infinite minus infinite, okay, they are fixed. Then 3 will be somewhere this side, suppose 0 is here, then minus 2 will be here. Now I have to draw this table. Okay, this table is, first I have to write the interval, sign of f dash x and nature of f. Okay, so interval. Now from this number line I have to find the interval. So first interval I will take minus infinite to minus 2, second minus 2 to 3, third is 3 to infinite. Okay, now I have to take one value from all these three, one value, and check whether answer is positive or negative. So minus infinite to minus 2, let us take minus 3. Okay, between this is minus 3, so I put minus 3 in this, let us put here, or you can put in maybe here, yeah, better to put here. So you put minus 3 here, so minus 3 minus 3 minus 6, that is minus answer, so I put here negative answer. Okay, then again the same value, put minus 3 plus 2 is negative answer, so it is negative here. So minus and minus, it will be positive answer. If it is f dash x is positive, f is increasing function. Okay, then second interval from here, minus 2 to 3. So minus 2 to 3, any value you take, let us take 0. If I take 0 and I put here, so 0 minus 3 means minus 3. 0 plus 2 means plus 2. So this answer is negative, this answer is positive. So negative into positive is negative. So if it is negative, f dash x is negative, it is decreasing function. Then 3 to infinite, take any value, let us take 4 and put here, 4 minus 3 plus 1, positive. 4 plus 2, positive. Both are positive, so positive, positive, positive. So if positive answer, f dash is positive, the nature of f is increasing. Okay, so we can say that function is increasing in minus infinite to minus 2 and 3 to infinite, and decreasing in minus 2 to 3. So this is the answer. Question number 6. Find interval in which functions are strictly decreasing or increasing. We are given A, B, C, D, E. Okay, functions are given and they have asked us to find the intervals in which they are increasing or decreasing. So first A is fx is equal to x square plus 2x minus 5. First we will differentiate with respect to x. So derivative of fx is f dash x square is 2x plus 2, x is 1, this is 0. Again equate with 0. So when you equate with 0, plus 2 you transfer here, minus 2. Divide by 2, so you will get x value minus 1. Here only one value has come. So draw the number line. So minus infinite to infinite and minus 1 will come in middle. Okay. So now you have to take one value, one this interval, one this interval. Okay. So interval, sign of f dash x, nature of f. So I take interval minus infinite to minus 1, another one is minus 1 to infinite. Okay. This interval. Now I'll take one value between minus infinite to minus 1. Let's take minus 2. Put here minus 2. 2 into minus 2 is minus 4 plus 2 is negative. So answer is negative. So it is decreasing function. Then minus 1 to infinite, you take any number. Let us take 0 in this interval. So I put 0. So 2 into 0 is 0 plus 2, positive answer. So positive. That means it is increasing function. So the function is decreasing in minus infinite to minus 1 and increasing in minus 1 to infinite. Question B, you try. I will do question number C. Fx is equal to minus 2x cube minus 9x square minus 12x plus 1. As usual, differentiate with respect to x. So this derivative is 6x square minus 9 into 2, 18x minus 12. From here I can take minus 6 common. So what remains here? X square plus 3x plus 2. I will equate with this with 0. Then minus 6, we just neglect it. We have to only solve for this. Minus 6 is there. We have to keep it. Okay. Though for finding the value of x, I will not take this. Finding the value only, I will take this value. Okay. So here comes, if I split the middle term, the factors I will get x plus 2, x plus 1 equal to 0. That means x is equal to minus 2 and x is equal to minus 1. Draw the number line, minus infinite, here infinite, minus 1 somewhere here, minus 2 somewhere here, 0 will be somewhere here. Okay, roughly we have to put. Then what are the intervals I get? Minus infinite to minus 2. Okay, first interval. Second interval, minus 2 to minus 1. Third interval, minus 1 to infinite. Okay, so this I have written the interval. Now minus infinite to minus 2. Let's just take one value. Let's take minus 3. Okay, keep in mind that there is minus 6 here. Okay, so I'll keep here value. I'm going to take minus 3. So this is negative answer. This answer is always negative. So first I have always written negative. Then here I am going to take now minus 3. Minus 3 plus 2, negative answer, minus. Minus 3 plus 1, again negative answer, minus. So minus into minus plus, plus into minus, negative. So it is decreasing. Then take minus 2 to minus 1, one value. Let's take 0 maybe. So first value is negative. If I take 0, 0 plus 2 means positive. 0 plus 2 means positive again. No, sorry, I will not take 0 because here minus 1 and minus 2 is there. So I have to take less than minus 1. So you take maybe minus 1.2 or minus 1.3 or something like that you take. Okay, 0 you cannot take because 0 is out of this. So when first part is negative, okay, but here when I put, it will come positive. Here I will put, it will come negative. So positive, negative, negative, positive, positive, positive. So it is increasing function. Then minus 1 to infinite. Here I can take 0. If this first one is negative, if I take 0, this is positive, this is positive. So positive, positive, positive into negative is negative. So it is decreasing. So we can say the function is increasing in minus 2 to minus 1 and decreasing in minus infinite to minus 2 and minus 1 to infinite. Question number E. D, you try yourself. Fx is equal to x plus 1 whole cube, x minus 3 whole cube. So first differentiate with respect to x. So I will differentiate here u into v. Okay, first I am keeping x plus 1 3 power 3 as it is. I differentiate this. So 3 x minus 3 whole square plus. Now I'll keep x minus 3 whole cube as it is and differentiate this. So 3 x plus 1 whole square. Now from both these I can take x plus 1 whole square, x minus 3 whole square plus 3 common. So here remains x plus 1 and here remains x minus 3. So here x plus x comes to 2x and minus 3 plus 1 minus 3, here there is a mistake. Here minus 3 plus 1 is minus 2. X plus x is 2x. So it will come here 2x. So you can write here 2x. Okay, it is 2x, not only x. Because here comes to be, okay, then you equate with 0. Okay, when you equate this with 0, 3 you will not equate, you equate this 3 x plus 1 whole square is always greater than 0, x minus 3 whole greater than this also square greater than 0, 2x minus 2. So all three I am equating with 0. So when I equate with 0, from here I will get x value as minus 1. From here I will get plus 3. And from here 2x is equal to 2 divided by 2. So you will get plus 1. Okay, so I have written the value here. Okay, for f dash x equal to 0, x is equal to minus 1, x is equal to 3 and x is equal to 1. Okay, I have drawn the number line here in this way. Okay, minus infinite, then I am putting minus 1, 1, 3, infinite. So I have got 3 intervals. I have got 4 intervals. Minus infinite to minus 1, minus 1 to 1, 1 to 3 and 3 to infinite. Okay, see I have written here. Minus infinite to minus 1, minus 1 to 1, 1 to 3, 3 to infinite. Okay, now we have to check the sign of the function, f dash x. Okay, so sign spelling is wrong. The sign, okay, okay. So now let us check it. Okay, so we check first minus infinite to minus 1. So you can take any value. Let's take minus 2 maybe. So you take minus 2 and place here. Okay, so see here this is square, so this will be, both will be positive and this also is positive. So these two will be positive. I am taking now minus 2. So if I take minus 2, this minus 2 into 2 is 4 and minus 2. So it will be negative. So what I have written is positive, positive, negative, which is negative total, so decreasing function. Okay, then from -1 to 1 you take 0. So when you put 0, what you get is positive, positive, negative, that is negative decreasing function. Then you take from 1 to 3, let us take 2 value. Okay, put 2 here. So now again you put 2 here, 2, this will be positive, this will be positive, here you put 2. So 2 into 2, 4, 4 minus 2 is positive, so all 3 are positive, so again it is increasing function. Okay, then 3 to infinite, you take any value, 3 more than 3, 4, 5, whatever you get, all 3 will come positive, so it is increasing function. So the function is increasing in this last 1, 3 to 3, 8 and decreasing in minus infinite to -1 and -1 to 1. So in these two interval it is decreasing, other two it is increasing. Question number 7. Show that y is equal to log 1 plus x minus 2x divided by 2 plus x greater than -1 is an increasing function of x throughout its domain. Let us take y is equal to this and differentiate. So log derivative is 1 by x. So dy by dx is equal to 1 by 1 plus x and x derivative is 1 minus this you have to do u by v. Okay, so I keep denominator as it is 2 plus x and I differentiate 2x. So 2 will be 2 and x will be 1. So 2 minus now 2x as it is and differentiate denominator. So 2 will be 0 plus x is 1. So I have written only 2x here. And in the denominator, square of the denominator, that is 2 plus x whole square. Okay. Now let us simplify here. So I will do dy by dx is equal to, also I am taking LCM. Okay. So 2 plus x whole square will come here and 1 plus x will go here and multiply here, and this also I will simplify. I will open this bracket and simplify. So 2 plus x whole square minus this one, 2 into 2, 4 plus 2x minus 2x. Okay, so I have written 4 plus 2x minus 2x, and this LCM I am taking, that also I am multiplying here 1 plus x, and in the denominator 1 plus x, 2 plus x whole square will come. This 2x plus 2x minus cancel, and then here remains 2a plus x whole square. Now, so I am expanding this a plus b whole square. See, I have expanded here. 2 square is 4, 4 plus x square is x square plus middle term 2 into 2, 4x. Then here minus 4 and I am multiplying here. So minus 4 into 1 minus 4. Minus 4 into x minus 4x and denominator as it is. So here also you can see plus 4 minus 4 will cut. 4x plus 4x minus cut, remains only x square divided by 1 plus x, 2 plus x whole square. Now here what happens? We know that x square is greater than 0. Positive, any square value is always greater than 0. Then 2 plus x whole square also will be greater than 0. And in the equation we are given x is greater than -1. That means 1 plus x also will be greater than 0, because this x greater than -1 given. So 1 plus x will be definitely greater than 0. So all these numerator, denominator, everything is greater than 0. So that dy by dx also is greater than 0. So we can say that function is increasing throughout its domain. Okay, we have shown that this derivative dy by dx is greater than 0. So it is the condition of the increasing function. Question number 8. Find value of x for which y is equal to x into x minus 2 whole square is increasing function. So I will take y is equal to this and differentiate with respect to x. So first I am doing derivative of x square, this power. So it is 2x x minus 2. Then u into v I am doing. So x as it is, differentiate x minus 2 will be 1 only, plus x minus 2 as it is, derivative of x is 1. So x plus x is 2x minus 2, and this 2x I am writing here. Okay, then from here I am taking 2 common and multiplying here. So 4x, x minus 2, x minus 1. Then equate with 0. So when you equate x equal to 0, x is equal to 2, x is equal to 1. Okay, so this 3 value I get. So if you draw the number line, you will get interval 0 in minus infinite to 0, 0 to 1, 1 to 2, 2 to infinite. Okay, and we will check the value for all these. Minus infinite to 0, you take minus 1. So if you put minus 1 here, minus 1, this is negative answer. Then you put here minus 1, this is negative answer. Put minus 1, negative answer. So total what you come? Negative into negative, positive into negative, negative. So decreasing function. Now second you take from 0 to 1. So you 0 to 1 you take 0.2 or something. So if you take 0.2, positive. If you take 0.2, this is negative. If you take 0.2, this is also negative. So both are negative and only this is positive. So positive, negative, negative comes positive. So increasing function. Then from 1 to 2, you take 1.2 or 1.5. So 1.5, first one is positive. If I take 1.5, answer 2 is greater, so negative. 1.5, 1 is less than 0, so positive. So positive, positive into negative is negative, so function is decreasing. Then from 2 to infinite, you take any number, take 3 for example. So this is positive, 3 minus 2 is positive, 3 minus 1 is positive, so positive, so it is increasing function. So we can say it is increasing in 0 to 1 and 2 to infinite, and decreasing in minus infinite to 0, 1 to 2. So you have to find the value where it is increasing. So 0 to 1 it is increasing, and 2 to 8. So I have written here, therefore y increases for 0 less than x less than 1 and x greater than 2. Question number 9. Prove that y is equal to 4 sin theta divided by 2 plus cos theta minus theta is increasing function of theta in 0 to pi by 2. Differentiate, so u by v, so I keep denominator as it is and differentiate first numerator, that is 4 cos theta minus sin as it is, derivative 4 sin as theta as it is, 2 plus cos, 2 will be 0 and cos is minus sin, minus this theta will be 1, and for this denominator is 2 plus cos theta whole square. Simplify, I'll open this bracket, 2 into 4, 8 cos, 2 into 4, 8 cos theta, 4 cos square theta, minus minus plus 4 sin square theta, minus 1, 2 plus cos theta whole square. This, if I take 4 common, this cos square plus sin square, which is 1, and this I am taking LCM and multiplying here, and then I will expand this also and then simplify. So here 8 cos theta plus 4, this I am expanding, keeping in mind this negative sign, so 2 square is 4, minus middle term 4 cos theta minus cos square theta. So 4 plus 4 minus cancel, 8 cos theta, 4 cos theta will give you 4 cos theta minus here cos square theta, denominator as it is. Then from here you take cos theta common, so you get here 4 minus cos theta divided by 2 plus cos theta whole square. Okay, this is what you get. Now we have to from here see that this is greater than 0. Since 0 less than equal to theta less than equal to pi by 2 given, okay, first quadrant, and in the first quadrant cos is also positive, or you can say the value of cos is always less than equal to 1. Okay, the range of cos is 0 less than equal to cos theta less than equal to 1. Here what you have done, 4 minus cos, that means this value will be not greater than 1. So 4 minus 1 maximum, so 4 minus 1 which is positive, so we can say 4 minus cos theta is greater than 0. Cos theta in the first quadrant is greater than 0, this is square, so it is greater than 0. So we can say that dy by dx is always greater than 0 for 0 less than theta less than pi by 2. Hence y is increasing function of theta in 0 to pi by 2. So we have done up to question 9. Today we'll keep this much. Thank you very much.